everybody. Thank you for coming to the talk. My name is Nayeon Lee, and I'm a research engineer at CAF's Mississippi State University. Today, I'm going to talk about the engineering design found in the created world. So I hope you enjoy this topic, and whenever you have a question, you can just raise your hand and then just give a comment anytime you have something to want to say. So actually, I did my PhD at Mississippi State University, and this is my like a big interesting topic in my life, and then I'm really glad that I can share those very amazing features that I found throughout my PhD, and then later with you guys today. So I think most of you heard about the bio-inspired design. So actually, bio-inspired design or bio-inspiration or biomimicry is a term that indicates the uses principle found in nature to develop new design. And one of the very famous example is Velcro. So Velcro was actually invented in 1941 by this person named Mr. George D. Mantek, Switzerland engineer actually. And then he found this bird seed stick to his dog after walking around, and then he was wondering why is it stick to his paw while the other seeds is not stick to the paw. And then actually with the engineering mind, he already trained as engineer, so he brought this seed under microscope and then found these very interesting microstructures that has a hook. So from that microstructure, he actually developed this Velcro with the texture, and it still uses like widely for the shoes and jacket and everywhere, like even for the electronic device. So actually, this is not like a just accidental revelation. He already trained as an engineer, and then like many people had seen those bird seed, but it was only him that who could develop the Velcro from the finding those engineering principles and apply to the new invention. So actually during my PhD, I looked at the woodpecker, and also one of my colleagues and my advisor, Marcus Meyer, looked at the ram's horn, like how they dissipate all the energy while they pecking wood or like ramming to each other. And from this investigation, we are not aim to like copy the structure like this way, but instead our aim was like how can we find, or how can we take into account the various parameters that are seen in biological structures and apply them to a new engineering design. And another very famous example from the bio-inspiration field is this high-speed train in Japan. So in Japan, they built all the high-speed train all over the country. And then here is the Sanyo Shinkansen on the southern part, and more than half of this line is composed of the tunnel like this. And then when train get into the tunnel, it happens with the compressed wave, like a compressed air. And when this compressed air released at the exit, it make a boom loud sound. And also because of this air resistance, they could not increase the speed of train over the 270 miles per hour. Although this can reach it further, but because of this problem, they cannot operate over this speed, and also because of the air resistance. So what they did was actually they see this bird. So you have any idea what this bird is? It's a kingfisher. So kingfisher is very famous for its silent catching fishes, and also it minimizes the water splash when it enters to the water. So they copied, basically they copied the shape of bill in the tray, and just copying the shape reduce the air pressure by 30%, reduce the electricity used by 15%, increase the speed by 10%, and comfortable ride for customers. It's amazing. But here, you see that I'm not ignoring the bird, but this bird would not understand that aerodynamics. That I need this shape of bill to uh, resist all the air or like a fluid dynamics resistance something. This bill has this shape of bill, and that is already optimized in terms of aerodynamics perspective. And then these Japanese engineers knew that this bill will work in terms of engineering. So it just not happen, but they understand what is the principle behind those geometry, and then adapt this geometry to the further develop the train, and it really worked. So this is bio-inspiration. How does bio-inspiration work in this work? This is another example paddlefish. So actually this study was done at here, calves, and actually paddlefish is very common in Mississippi River here. So and this paddlefish is very unique features with the long bill. So the use of bill is like sensing the electricity inside of the water. So they can detect the plankton or some other like fishes or other barriers inside the water. Especially, it's very helpful in the muddy Mississippi River. So actually my colleague Jeremiah Diang, he brought the paddlefish and did some mechanical testing to find the material properties, and also he constructed this 3D model to see how this structure worked to resist the bending at the water. And you can see the stress is very uniformly stressed out through the structure. And this is very important, not to have stress concentration in a structure, because usually if you have stress concentration in one spot, that causes failure more likely. And when you see this structure, oh, okay, so this is quite doable. It's easy design, right? But actually, it's not easy design, because when you think about cell tower, there are a lot of cell tower failure or all over the world, and this failure is due to the structural design, some fail of structural design. And this is not long time ago. This news I just found that it happened 2 years ago in United States, and this one is just 4 to 5 years ago, and still it happened. So compared to this man-made like a design, we can see how much this design is elegant, and then secure the structural integrity for this little fish. So maybe to construct something big, some structure that required the bending resistance, then maybe we can get some inspiration from the paddlefish. And another example is woodpecker. So this is it was my PhD topic, and woodpecker pet tree with a speed of 6 to 7 meters per second, and deceleration force is even greater with 1,000 force, gravity force, so 1,000 times of gravity. So each time it packs, it doesn't. Woodpecker doesn't have any concussion. It can pack the tree like all of its lifetime. And there were some researches on what kind of feature would be responsible to keep these woodpeckers from concussion. So here's some very interesting features found in woodpecker: thin neck muscle, third eye, inner eyelid, and thick skull. Like a skull is thicker than compared to other birds. And also very interesting. One of the interesting features is the tongue bone, hyoid bone. So tongue bone is extended through it go throughout the skull and ended up here. So actually this structure is very interesting. Actually this structure follows a golden ratio, like a ram's horn or like a seashell. This is another very interesting features, but features that I want to share with you today is the beak. I only I see only one part of the bird, not all systematically, but the part of the beak. So if you see the microstructure of the beak, the beak is comprised of keratin scale like a finger, and this keratin scale is very elongated in woodpecker, so they can maximize the friction when to them the energy, to them the impact. And compared to other birds like a chicken and toucan, it's very obvious, very clear. Also, if you see the inner layer of the beak, actually the beak has 3 layers. So this is the exterior outmost layer, and this is the inner layer composed with the bone, and the bone of the woodpecker has less porosity compared to other birds, so it gives the structural strength when it packs the tree. And the last feature that I want to share with you is the wavy lines inside the beak. And this line is nanoscale. Like this bar is 1 micron. So this is nanoscale suture lines inside. And also there is another like a suture found in chicken and toucan, but woodpecker has more wavier lines compared to other beak. So it was a pretty interesting finding. So I ran the FA simulation to see if really this structure is responsible for the energy absorption. And actually, if you see this geometry, actually this geometry from the geometry, if you see the elastic wave propagation, then when the elastic wave propagated and then meet some boundary, it reflected or refracted. And also the elastic wave has 2 kinds of wave. One is longitudinal or one is a shear wave. So if you have like a slinky, so if you have a slinky, so like this one is normal wave, like this one is normal wave, but this one is a shear wave. So there are 2 kinds of wave. And if this wave, elastic wave, encounter this some curvatures, then it either deflected as a longitudinal wave to other directions, or also it can transfer to shear wave. And with this theoretical background, theoretical explanation, some theories, my team actually simulate, like run the simulation using FEA, and then found that this sutured bar transferred as one is like a normal wave, like the incident wave, transferring to the like a flexural wave and shear wave. while if there's a no suture bar, the normal waves just go through as a normal wave. So actually, this suture bar is actually looks very simple seemingly, but in engineering point, it actually diversified the normal wave to other several waves, so that the like a woodpecker can avoid the concussion from the one normal wave impact. And next example is ironclad beetle, and this research is just published this year. And also this work was done here at CAS. So ironclad beetle is so tough and strong that it can survive getting over by car. And actually, the ironclad beetle generally lived in the Texas area. So we got this sample from the Texas A&M. So here from the ironclad beetle, I want to share 3 very interesting features, from the engineering point of view. If you see the surface of the beetle, we can see those very regular periodic structures. And when I first see those structures, it was very interesting. Why there is this kind of very periodic, beautiful nanostructures on the surface? And then after that, I started to do some literature reviews from entomology department, or from any plant biology, or a lot of biology community. And then actually I couldn't find the answer for this beautiful periodic nanostructure. But considering the size of a microbe, which is about 2 to 10 micrometers, this one is quite matched to the microbe size. And then I found another article that say the dragonfly's wing has very strong antibacterial properties. So several scientists intentionally put the microbes SRS or E. coli on the wing, but later they failed to even adhere to the surface because of these nanostructures. And also, this is lotus leaf. Lotus leaf is quite famous for its properties of the hydrophobic properties. So the water is not adheres, but it has some self-cleaning functions. So very similar structures found on the surface of beetle. So we are trying to fabricate very similar structures on the biomedical devices, and then see if it really works. It's very interesting. And another interesting point is, if you see the cross section of the beetle, you can see those fibrous stack. And those fibrous stack is pretty interesting. But even more interesting feature is those fibrous stack has overlapping area, around 5 to 10% of each layers are overlapped. It might not impressive that much to you, but from the point of composite engineering, it's really amazing way to secure each composite layer without delamination. Because for the composite, the delamination is the #1 failure cause. So actually, to prevent the delamination, what engineers do is they do stitching. So we have several other orientation of the composite, and at the last step, doing stitching of the whole different orientation of the composite. But actually, what this beetle shows is they overlapped each orientation of the panel. So delamination is not occult. It's really wise way in terms of the structural design. And the last one is, if you see the beetle, all kind of beetle, they have two half on the cuticle, like a left side and right side. And the way the left side and right side is connected is not glue or not either other things, but they are interlocked using this structure, interlocking structure. So this is actually, yeah, it was me to take this picture. It was very, very interesting. And it was not just me. So Purdue, so the name is Jesus. The Purdue researchers do the simulation, how much this interlock can resist the mass, and they found that 3,900 times of the body mass can be resisted by this interlocking system. And how it worked is actually this is the same principle like you have normal direction force, and this interlocking system is diverses these normal forces to shearing, and also that's how they can resist that big mass, big force over the cuticle. It's amazing, actually. It's all engineering design. It's not just like some spontaneously happen, but from the engineering point of view, it's really amazing. And actually, in the research, there are a lot of styles. So if you see Niels Bohr is the one who actually do the study on atomics and quantum physics. So in this case, this is like it enhanced the fundamental understanding in science and for the society. And consideration of use, like uses like Edison, seek the solution or give some better device to make a human life better. But the combination of the understanding and use is this area with the knowledge and solution, and the example is past tense. So to make a better solution, actually, in these areas, research requires the better understanding of the science and principle of the physical world. And I would say the bioinspiration is in this word. Like this bioinspiration, this is not just happen, but it optimized design in terms of the engineering principles. And so far, we are talking about the part design that found in the nature, but also I want to mention about engineering system. So at the system level, how it is optimized. So this is even more complicated, but I just want to touch about from the systematic level. So this is me, and then this is my second son. So actually, while I was pregnant, I was wondering about this this issue, this concern. So actually, I dig into a lot, and I found that it's worth to share with you. And actually, one thing that I want to mention is no naturalistic account for non-reproducing living matter developing into living creature capable of reproduction. So reproduction system cannot be explained with the account of Darwinism so far. And also the big question that I had was, in order to sustain maternal body and fetal body, there should be an optimizing point regarding immune system. So what that means is immune system is necessary for survival. So during this COVID pandemic, the immune system was one of the hot topic. So we need to develop the immune system to fight over other non-self entities. It could be virus or bacteria or anything, any proteins or any material. And also the fetus baby is non-self. The baby is not me. It's individual entity, but still stay inside of maternal body for like 40 weeks without attacking by immune system of maternal body. It's very big problem, like a conflicting problem, because survival is one big pillar in evolution theory, and also reproduction is another very important portion to keep this whole living world keep continuing. So we need both at the same time, but in a gradual concept, it cannot be developed at one time as a system. Like this component and that component is conflicting to each other. So actually this one is a long-standing question, and still it's a long-standing question. And so far, what scientists revealed was there is a decidual, like a little membrane over here. So this membrane may change in DNA of maternal body. So to deactivate the chemokine genes, the chemokine are not expressed, and T cell are not expressed, and T cell are not recruited to the site of embryo implantation. So it protects from the outside of the placenta, and also this placenta secrete enzyme to avoid detection by the immune system. Also, fetus have lymphocytic suppressor cells to inhibit maternal cytotoxic T cell. But this is not enough. This is just a little bit of features to deactivate the maternal immune system for the fetus, but it's not enough. But still, we need to protect the fetus from the bacteria or virus, that kind of thing. So, selectively, placenta does not block the maternal immunoglobulin G antibodies, so it can pass through the placenta, providing immune protection to the fetus. And it requires it's a systematically, it requires immune system for the maternal body. The maternal body need the immune system, but also at the same time we need the protecting system for the fetus. So this system should be on set at the same time to enable this life keep going. And very amazingly, the Bible already mentioned that I praise you, God, because I am fearfully and wonderfully made. Your works are wonderful. I know that full well. Maybe for the Westerners, it's like a common sense. It could be a common sense, but for me, like an Easterner, it's quite very impressive. Like God already made this comment on the Bible like a few thousand years ago. And so actually, using those, I mean, I showed a lot of examples of engineering, like some seemingly, I would say seemingly look like engineered part or engineering system. Then, what can you think using those evidences? And I would say there are two models to explain the natural world, and one is naturalism, and the other one is creationism. So we have a lot of data from past. We have from the past, and also using that kind of data, we can postulate about the origin and also existence of God, and also natural history of the earth, and also using those models that establish it on the evidences that found in the nature, or usually nature, we also can think about the present. If that is true, or the other one is true, then what about ethics and values? And what about the purpose of life? Then we can also make a prediction about the future. So why I talk about this is, yeah, I know, like people say, there's a lot of people who are arguing about naturalism versus creationism, or like evolution is true. No, creation is true. A lot of people arguing, but most of people say, okay, you argue, it doesn't matter to me because it happened. It happened long time ago, and I'm focusing in my present life. This is not a big matter to me, but I would say that is really big matter to everybody, because according to what word you're choosing, your interpretation about the past, and your mindset for the present, and the prediction to the future can be different. It will different amazingly. It's like a two different paths. So what naturalism believes is, this one is believed that only natural law and forces operate in the world, nothing else. Only law, natural law, and materials is done. Matter is the fundamental substance in nature, and mind, conscious are result of material interactions. There is no purpose in nature and history. Spirit, deity, ghosts are not real. So the as a naturalist, the most important thing in this life is just physical well-being. That is the most important thing, because the material is the one that is always be. And as a creationism, this is a belief that God created time, space, and material and life, and magnificent orders and beauty in nature, since the nature was founded by God's wisdom and knowledge. And position of human is different from animals, because God was placed the human in a different position from animals, and there is no purpose in nature. There is purpose in nature and human's life, because there is a designer for the whole world. And here I just put a little thing. So what about theistic evolution? There's a lot of people who believe theistic evolution, like God used the evolution, the method of evolution to create the world. And I would say theistic evolution is more like some monstrous theory, because evolution is basically developed to explain the world only with the material, without any supernatural intervention. That's what evolution aims. And theistic is like a God. There is a God. There is a supernatural. There is some intelligent being outside of this system. This is the creationism. This is a theistic one. And if you put these two words in a one word, then it become very monstrous. So it become either very naturalistic way to interpret the supernatural way, or it just usually abandon the theistic part and more become an evolution way. So I would say the naturalism and creationism cannot be overlapped in this way. Actually, philosophically, because their assumed preposition is very different. And here's the modern history of the science and philosophy. So about 1500, there was a Protestant Reformation, and followed by scientific Reformation. So during this time, actually during the scientific Reformation, actually there were a lot of good-minded scientists who interrogate nature using scientific method. And although God created this world with wisdom and knowledge, which is intelligible by human, that is created by the image of God. Those orders and rules that operate the natural world, is not revealed to everybody. This is very subtle, and like and also very highly ordered. So this is not simple. That order and rules that got put on this world is not simple things, and it should be like described using highly developed mathematical descriptions. And actually, why I thought about this one is this scientific reformation is very unique period. Only happens in Western world. Of course, in Eastern, we had a lot of developed form of literaries or like a mathematics forms or a lot of like a developed some civilization cultures, but I would say in terms of this scientific reformation with the whole developed mathematical formations and to explain all, and also like investigating nature using the scientific method like isolating variables and then um, and do all the experimental work. So it's not easy. Like if you think of like a Robert Boyle or Isaac Newton, they spend whole life. They spend their whole life to investigate, to develop just one equation out of this world to see what kind of like a rules orders operate the gas molecules or like the gravitation, that kind of things. So this one was not easy things, but actually, what enables those bright-minded scientists conducting this scientific investigation is the conviction that this world should be created by God, who has superior intelligence, who has exceedingly great knowledge. And actually, that one was written in the Bible. So that's how they motivated to investigate this world with a lot of effort. So actually, you may already know that the actually one big event that enables Protestant Reformation and scientific Reformation was Gutenberg brought the printing technique that happened during this time. So actually, before Gutenberg, there was only 30,000 copies of the Bible on the Europe in Europe. But after that, like within like 100 years, there were like 12 million copies of Bible was available in European land. And but during this time, people found that a lot of physical laws that gives quite predictive regularities. So people try to think that if we give quite good initial conditions, then those natural law would be able to make this current state of the living creatures or current state of the cosmology or current state of the geological features. So that's how people like brought the Enlightenment idea, and then during this time, this period of time during the 1800s, people like argues that maybe the just material will be enough to explain the origin of the whole world. So from this time, the European country and now for the present all worldwide like embrace the evolutionized idea greatly, but the America is quite exceptional. Like I mean, kind of exceptional because there was American Civil War occurs during this time. So publication of species of origin largely unnoticed until the end of 19th century in America. And also, America has a very good foundation of conservative Christian faith. So that is another resistance for the evolutionary idea. But if you see this chart, this one is just published in 2013, and this is survey of the fellow of the Royal Society in UK. So you can see in the academic field, a very large population, large portion of the academic faculties or either scientists reject God's existence, and this one is like a possibility of the faith, and like a faith or religion and science can be coexist. But most of people say no, it's impossible to coexist the science and religion together. So this is not only the UK's case, but I would say this is all over the world. It's the phenomena that that can be seen all over the world, and not just academic field. I would say the mainstream of the culture or like a textbook and like mass media is more based on the naturalism instead of the creationism. So maybe this trend will be enhanced as time goes on. But what I want to say is, although this is the trend of the nowadays, it was we don't need to be in that trend, because today what I want to say is although this enlightenment movement and then this some endeavor made during this time says we don't need any supernatural explanation to account for the origin issue, but I would say if you really see the natural world, it could indicate the other way actually. And actually, I would say in the building a model, the most important part is validation. If you set up the model, you need to validate. You need to validate if the model is really worked. So what I want to say is, let's validate the model. Let's validate if the naturalism worldview is really work, and it gives the right explanatory things for the world. So, and here's another the one very famous scientist that I want to show is Sir Isaac Newton. So everybody knows the Newton, and he lived during the scientific Reformation, and then he is founder of calculus, law of mechanics, universal gravitation, optics, binomial theorems, and he is a president of the Royal Society. So Royal Society is the same the community that this survey was conducted, and actually Newton was the president of the Royal Society at UK. And actually, he mentioned this, like, King Solomon is the ultimate hermetic authority. I have spent many thousands of hours unraveling his teachings. The configuration of Solomon's temple enables me to develop an image of gravitation. I described the ancient temple in one of my notebooks as a fire for offering sacrifices that burned perpetually in the middle of the sacred place, and I visualized the center of the temple as a fire around which believers assembled. It acted as a metaphor. The disciples represent the planet, and the fire represents the sun. This image gave me the idea that there was an invisible force that acted between all of the objects. The reason why I read all things is it's really inspiring. Like before Newton, we didn't know there is like a gravitational force. But that is force acting to some other separated entity without touching. So actually Newton can describe how gravitation force acted with with the m1 m2 divided by like the distance square. but what intrigues him, like provoke him, was then what is the cause of the gravitational force? Why? Where it comes from? What caused the gravitation force. And this is from the Principia, the masterpiece book that Newton wrote. And he said, this one, the gravitational force is the invisible force that acted between all of the objects, and still he's still thinking like, then what is the gravitational force? What caused the gravitational force? And he kept saying that gravity is a universal force. There is some underlying way in which forces can act over empty space. I believe these forces act through the spirit of Jesus Christ. He is not outside the universe, but a part of it, a unifier. However, by one means does he keep the planets in motion and particles moving. He used gravity and these other mysterious forces. But how? I questioned this for a long time. I implored God to tell me. This is really intriguing to me as a researcher. Like if I always face the problem, and then Newton implored, asked God to tell me why. And then in the flesh, in a moment of divine inspiration, it came to me. God revealed something to Newton. God used body, the essence, the spirit of Christ as a medium for these forces. God's Son became incarnate once before, but he is immortal, pure spirit, and he can take on any form. He can guide the atoms of the universe. He may steer the planet in their paths and make the sun to burn with fierce flame. Do you believe he can guide the atoms of the universe? I mean, I believe it because Jesus made up the alcohol from the water. It is like Jesus guide the atoms to become another materials. He can guide the atoms of the universe. So this is amazing. Actually, this is amazing manifestation of God in the research work. And this is the comment on the design. The most elegant system of the sun, planet, and comet could not have arisen without the design and dominion of an intelligent and powerful being. And if the fixed stars are the center of similar systems, they will all be constructed according to similar design and subject to the dominion of one. He rules all things, not as the world soul, but as the Lord of all. And because of his dominion, he is called Lord Jesus, that is universal ruler. So this is how he confesses his faith in terms of his research work. And this is not only affect his faith and life, but it still affect us, affect our whole research, and not only research, but also this technique that we are using all over the world. And there's another food scientist comment that I want to share. So those are both lived during the 20th century. And then those people mentioned about the chance. The complexity of living system can be emerged by chance. And Fred Hoyle, he said the chance that higher life form might have emerged through evolutionary process is comparable with the chance a tornado sweeping through a junkyard might assemble a Boeing 747 from the material therein. And Francis Crick, who is famous scientist, is deciphering the helical structure of the DNA molecule. An honest man, armed with all the knowledge available to us now, could only state that, in some sense, the origin of life appears at the moment to be almost like a miracle. So, actually, although the current trend says that most of the scientists reject the God's existence, and then I even heard that how could scientists believe supernatural being? How could scientists be a Christian, attending church? But actually, there are a lot of examples that, I mean, not just example, but like a great-minded scientist, confess the faith, and they do all the research work under the umbrella of the supernatural power created this world. So here is the argument. How was a car created? How was a car created? This little engineering system. How was a car created? So this is the have like a center for the advanced vehicular system. How was a car created? Was it natural law or someone who understands laws of the physics? It's very obvious. The first automobile was invented by car bands. So actually to make this some engineering system that operate well, there is someone who really understand what is the physics law to run those systems, and then put all the parts like this. This is almost the last part of the presentation, and Leo Tolstoy wrote this sentence. So actually, this is the first sentence of the novel Anna Karenina. Happy families are all alike. Every unhappy family is unhappy in its own way. So this is actually very famous principle. People say this is Anna Karenina principles. So in statistics, like one build like a hypothesis. I build a hypothesis, and then that hypothesis can be known in several ways. This is the Anna Karenina principles. But I would say healthy bodies are all alike. Every unhealthy body is unhealthy in its own way. It's very obvious because healthy body is all alike. But since every unhealthy body is unhealthy in its own way, so we have like eye doctor, skin doctor, like ear doctor, bone doctor. We have a lot of specialists because unhealthy is in all own way. And again, I can rephrase this sentence like functional cars are all alike. Every unfunctional car is unfunctional in its own way. Right. Like you can have engine problem or you can have wheel problem, like a lot of problem happens all the time. But can you see the big picture? Like the thing that I want to say is there is a master plan for the car and for the human body and even for the family. Like there's a master plan for the perfect system actually. This is not spontaneously happened like without any plan or blueprint. There is a blueprint. There is a master plan to make a wholesome system that work perfectly without any deficiency. So there's a master plan. If you agree there is a master plan, then next question is then who made the master plan? Who designed? Like who made this master plan? So today I talked about cuttlefish, like a lot of other animals, human body, a little bit of a human body, like a human body system. Also, Isaac Newton implored about the planet and systems. Then, what those are indicating? So, like from those evidences, from the actually, it can be explained in a lot of ways. But today, as an engineer, I only talked about those kind of things from the engineering standpoint, and I'll say those are indicating just one thing very clearly, very obviously. And since next week is Thanksgiving, like Thanksgiving is, I understand this Thanksgiving is very important historical holidays for Americans, but also I want to encourage you to give right thanks to the one who designed this world and us this wonderfully and beautifully. So and actually this is not a new idea. This idea was written from the beginning, and so far it's available to us. And so this is the end of the presentation. And any question or comment?